and means one at a time, right? And or means right. So and or one at a time and is all together. Look at this question. Can you tell me what should be the answer for the question number 2, example number 2? I'm replying, I'm waiting for your reply. Give me the answer for this. Can you reply for this answer question? If there are 3 routes from A to B, so I will write this way. Wonderful. Who got the answer? Sankeet got the answer. Sankeet, Hussein, A, B, C, and this is D. Dhanush got the answer also. Now, A to B, how many routes are there? There are 3 routes, isn't it? There are 3 routes. And B to C, look at this B to C. How many routes are there? There are 2. Sorry, there are 2 routes only. B to C, 2. And again, A to D also there are 2 routes, right? And also again 2 routes, right? So I have a 2 option. One option either this way, or I can travel either this way, right? So can you say that the 2 I can travel from A to B and B to C, this is one, or I can travel A to D and D to C. Very, very simple. So A to B, how many ways? 3 ways. D to C, 2 ways. A to D, 2 ways. And D to C, 2 ways. Or means what? Plus, this is into, of course, I'll get the answer 10. There are 10 ways to go from A to C. Right answer, everybody? Right. So here we go for the next one. I mean, Navin sir was talking about the difference between these two. If you look at the screen, you will understand the meaning of permutation, the meaning of combination. What is a permutation here? Arrangement of things. This is very, very important. The word arrangement, important here. What is the word given here? Selection. That is a combination. The order of things does matter. Order is very, very important. Right? What about here? The order of things has no importance. What is example? This is one example. There's a number lock, right? This is a number lock. Let's say I set the the passcode, that is a 786. Now we do care about the order 867 won't work. Let's say I'm telling you 1, 2, 3, given the 3 slots number lock, and every slot we have 0 to 9 digits, every slot, and you know this, every slot 0 to 9, and I have set the password that is 129. If you write, if you plug in, if you put it 219, of course that is not the proper the passcode what I fixed it. So it means the order does matter. The order, 1 should be the first place, 2 must be the second place, and 9 must be at the third place. If I'm telling you to find out the maximum trial to get the lock unlocked, this is my passcode 129. Maximum trial. Right, so what could be, of course, at this way 10 ways, of course at this slot 10 ways, I can also put here 10 ways, all together I'll get 1000 ways, the maximum trial I'm talking about, remember, right? So of course the combination is just the selection, right? So let's say out of 4, look at this one example is given there. My fruit salad is a combination of apples, grapes, and bananas. The order does not matter, right? The order does not matter. But in the case of permutation, the order of the things does matter. Very, very important. So once I fix the passcode 78786, if I'm writing also 876, of course will not unlock the lock. So I have to get the same way, same order 786. I can unlock the lock, right? So permutation is the arrangement. That's all, and the combination is a selection. So we'll try the few. Will Right. Look at this here. Now, can you tell me which example belongs to combination? Navin sir was talking, I think this one also. So, can you tell me? Very first one, very first. Picking a team of three people from a group of 10. What should be? Combination. Group. Great. Listing your three favorite desserts in order from a menu of 10. What should be? That is a permutation. How many words can be formed using all the letters in the word Robin? What should be? Again, the permutation. Now, how many words can be formed by using the letters of the word director, so that vowels are always together? Of course, ask the question whether does the order matter. Of course, we'll ask yourself the question: does the order matter? Yes, it does matter, right? So this is the again permutation. What about here? In how many ways can a team of seven be chosen from a pool of 20 individuals? Of course, the combination, isn't it? Very, very simple. I hope you understood, because I need to choose seven members out of 20. So it does not matter I'm choosing which person the first time and the second time, third time. I need only the seven people all together. That's all. It could be any seven. I'm not saying. That's why I always tell in the class, uh, selecting any seven out of 20. So I'm not telling this seven. One, the first person should be this, second person should be this, third should be this. No, I need any seven person I can select out of 20. I hope you understood. Very simple. I'm leaving to you. Next one is we'll try the questions based on here. Important concept. Here we go. Can you unmute yourself, my dear? Unmute yourself. Can you unmute Pavan? Right. Arrangement of numbers. What is the meaning of this? So we'll try to understand. Everybody. Uh, very simple. Just how do we arrange the numbers? And of course, the topic is the permutation. Everybody knows this formula. Just I'm reminding you people. NPR. Where is the formula? What is any number of elements? R is the number of slots. Number of slots or number of position, I can say. And you know this the formula. That is n fact, no problem, Pawan. N factorial, n minus r factorial. Right? We know this. Remember, there is one n must be greater than r. N must be greater than r. And remember, I am telling this formula, but I will not use it. I use hardly this formula in the permutation while counting, right? While counting the number of possibility. So of course, I will not use the formula, but I am telling you why I should not use the formula, and you can use the formula. I'm not, but I suggest if you try to understand practically this question, this is the first part talking about the permutation, not the combination. So I'm talking about the permutation, the first part. So we'll try to understand the formula first, and then I will tell you how we'll proceed further for the next couple of questions. I'm telling you, friends, let's say there are n number of elements is six. Let's say the six people, and there are 4 chairs. How many people? 6 people, right? 6 people or 4 chairs. Or let's say I'll write here one, I'll two, three, four. Let me solve it. The 4 chairs. Now at the first chair, first chair, how many ways a person can sit at the first place? Of course, we'll say, sir, any one among six, right? 6 ways. I am saying any one among six. So I do not know which person is sitting at the first place, right? I do not know. So that's why I'm telling any one among 6 members can occupy the first position. Now remember, of course, any one person would have taken the chair, any one person among six, right, would have taken the chair. So how many persons left out remaining? Of course, the 5 members. So for the second position, how many ways are possible? Any one among five, right? Now, remember any two persons would have taken the 2 chairs, the first 2 chairs. So how many persons left out? Of course, 4. So what about the third position? Any one among the remaining 4, and so on. What about here? Any one among the remaining 3. Now again you ask the question yourself, should I multiply them? Should I add them? So you will ask the question yourself, will I take all this together or one by one I am taking? So I am not taking either the first position or the second position or the third position or the fourth position. I am taking all together. Together means the and. I should multiply them and, right? So what should be the answer? 6 fives are 30, 120, 123s are 360, right? Now, if you use the formula, so what should be 6p4? Let me solve using the formula. So how do you write? 6 factorial will write, divide by 6 minus 4 factorial, right? So 6 factorial divide by, of course, so 6 into 5 into 4 into 3 into 2 factorial will get cancelled if you tell me, right? So if you look at this, I'm getting the same answer here, isn't it? Exactly the same answer. So using the formula in the permutation, right, does not make sense. If you using the formula, you should understand how we are using the formula, right? Before using the formula, you should have a very clear mind why I'm using the formula here. I want to arrange the 6 members, 6 elements in the 4 different slots, right? We're going to arrange the first position. How many ways? 6 possibilities are there because any one among 6 can occupy the position. Second position, how many ways? Remaining 5, remaining one among 5. Third, remaining one among 4, and the fourth position will be occupied by one, any one among remaining 3. So very simple. If you use the formula, do not use the formula, does not make any difference. So I would request you, we should not use it. Let's solve using the fundamental counting principle only. Just finding the number of possibilities at the different positions will get the answer. Here we go with the next question, friends. चलो यहाँ पे चलते हैं. I'll give you time for 10 seconds. You give me the reply. You give me the reply. Anybody? Anybody? Uh, 210. Who got the answer 210? Sankeet got the answer 210. Okay, Sankit, are you sure? Sankit, can you check it once again, my dear? I think you got clean bold. Uh, Shreya Sanjana 840. Okay, I hope is right answer. I don't know how did you solve it. So I am solving it using the fundamental counting principle. So how many numbers I need? I need four digit number. So I'll just create the position one, two, three, four, right? And there is no condition at all. The condition is without repetition. It means I should not repeat the digits. So of course many beginners will think this way. So one number is possible, one, two, three, four, possible. Why not possible? Also possible two, one, three, four, right? Also possible three, one, three, one, four, five, right? Also possible four, one, 4, 1, 2, 3, right? Possibility is there, right? So many. Of course, I will not solve manually. It'll get time. So at the first position, I'll find out the number of ways. Yes, Priyanka, Lavanya got right answer. At the first position, how many ways are possible? Tell me. I can plug in one here, no problem. I can plug in one also. I can plug in two also. I can plug in three. I can plug in four, five, six, seven. Or, you know. So one at a time. I can't put all the digits together, right? So of course I will put one by one. Either one or two or three or four or five or six or seven. Suppose at the first position, seven ways. Any one among seven. Very, very simple. Now, can you can you turn off your speaker? Anirudh Kulkarni, please, Anirudh, turn off your speaker. Okay, so now one digit has been put up. How many remaining digits left out? You will say any six, right? I don't. You should not say six. Say any six because I do not know which digit has been put up at the first position. I do not know, friends. So any six, right? Here, any six. Now what about here? Any one among remaining five. Remember, right? Now what about here? Any one among remaining four. So again, ask the question, Anirudh. Anirudh, I will request you to turn off your speaker. Seven. Now, should I multiply? Should I add? I should multiply. Seven into six into five into four. Of course, I'll get the answer 840. Right? I'll get the answer 840. So remember the fundamental counting principle is much more important, right? So now many beginners I am telling you, will use the formula. What is formula here? NPR, right? What is N here? Number of elements 7. What is R here? Slots, that is 4, right? So 7 factorial, 7 minus R factorial. So 7 factorial divide by 3 factorial. If you solve it, expand it, of course I will get the answer what we got using the fundamental counting principle. That's all. That's my answer. Right. We will go with the next one. That is the 2. Yeah. I'm waiting for your reply, everybody. 10 seconds. Tell me reply. How many four digit even numbers, right? Even numbers can be formed without repetition of digits. Remember, given without repetition. Digit should not be repeated. It means that I cannot say 1, 2, 2, 2. That is wrong. In fact, it's the even number, but I cannot say because the digit has been repeated. Should not repeat the digits. Anirudh, are you awake? Are you alive? Can you put on your switch on your speaker, switch off, switch off your speaker or put off. Anirudh, right? Any answer? Anybody? Anybody? Any idea to get this answer? So Nikhil 504, Nikhil clean bold. Shreya 210, clean bold. Sanjana, Srijit, Sanat, I hope. Right answer. Right answer. Sanat. I don't know how did you solve it, but I will try solving for everybody. So I am solving as a beginner, let's say, and then I will give you a trick also how to solve it, and also the methodical way, traditional way we'll try it. As a beginner, I am solving it. Look at everybody. Of course, using the fundamental counting principle, right? So I am solving as a beginner. Look at this. Of course, the question says using 1, comma 2, comma 3, comma 4, 5, 6, 7. How many four-digit even numbers, right? Even numbers can be formed without repetition of
Stop.
digits.
Stop. Stop.
Anirudh, what happened, Anirudh? Anirudh,
It was by mistake. Sorry.
no problem, Anirudh. Are you playing games?
Sorry?
Are you playing PUBG?
No, no, no.
Are
Nothing.
you sure, Anirudh?
Yeah, I'm sure.
Thank you. Thank you. I hope you are listening.
Yeah.
Okay, Anirudh. All the best. God bless you. Right. I'm just solving it, this question as a traditional, as a beginner, because Anirudh was speaking to me. I think Anirudh was solving the question. I hope Anirudh you will get the answer. So I am waiting for your reply, the answer. Right. Look at here. This is the seven participants are there. Sorry, there's seven digits given here. So I'm solving as a beginner. So I'll create the position first. One, two, three, four. Right. Now the condition is that should be the even number. When will get the even number? The last digit must be the even number. Very, very simple. So first I will try to fulfill the condition and then I will go for the finding the possibilities for the remaining positions. At the last position, what should be? Can I say, let's say, can I freeze 2 here? No problem. I'll freeze 2. So whatever I'll get the number here, any numbers end with 2, of course I'll get the even number, right? So this is one possibility. Of course I will get so many numbers and so many numbers and with ending with also 4 will be the even number, my dear, right? Also I will get so many numbers end with 6. I'll freeze it. So I am freezing the position at the last position with the 2, 4 and 1. I'm freezing it, right? So now we'll try to find out how many numbers and how many numbers I will get ending with 2, how many numbers I will get ending with 4, and how many numbers ending with 6. I will try. So or means what? One at a time. While I'm solving this problem, I will not look at these two problems now. I'll now after fulfilling the condition at the last position, I will come back to the first position. Remember, I should not go from here. I should go from the first position now. Now, among 7 digits, any two has been put up. 2 has been freezed up. So how many remaining digits are there? 1 we have, 3 we have, 4, 5, 6, 7. So remaining we have 6 possibilities. So I can plug in any one among 6. Now, what about here? Any one digit has been put up here, any one digit, and one digit has been put up here. The 2 digits had been used up. How many left out altogether? Of course, out of 7, 2 has been put up. So 2 have been put up. There is 5 digits here, right? So any one among 5 possibilities, and remaining here, any one among remaining 4. That's all. If you look at this, we multiply, of course, I'll get all together. I need all the 4 digits together. That's why I'm multiplying it. 6 into 5, 30, and 30 into 4, 120. I hope you understood, friends. I will get 120 numbers ending with 2. It means I'll get 120 even numbers ending with 2. If you're solving the remaining 2 possible cases, this case, one more case is there, one case, other case, third case. Now we'll try the second case. Will I get the same number of numbers? Let it check out. So this is 4 here. Watch out very carefully, friends. 4 has been used up. Remaining 6 possibilities. Remaining 1 among 5. Remaining 1 among 4. Of course, I will get the same way. I'll get again 120 numbers ending with 4. Will I get the same here? Of course, pretty much. So 6 has been put up, right, out of the 7 digits. So remaining 6, any one among 6. What about here? Any one among remaining 5. What about here? Any one among remaining 4. Again, I'll multiply. I'll get again 120. Isn't it? So of course, I will get all together how many? 360 numbers. So Aishwarya, Sanat, all this smart minds, you got the right answer. Now, of course, no, many beginners will not try this way. The smart minds will try this way only. Only one statement, only one line. One, two, three, four. Last position, how many ways are possible? You will say three. Two possible, four possible, six possible. So how do we say? I can plug in the last position with two or four or six. It means three ways, right? Three ways. So or means what? Any one at a time. So remember, any one digit has been put up. Remaining how many ways? Six ways. Again, any one among remaining five and remaining four ways. That's all. If you multiply all this, I'll get the same answer. Rest 360. Remember why I'm getting last three here. So, of course, last three means any one at a time. Or means what? I can plug in two or four or six, right? So, any one at a time. So, any one at a time has been put up. Remaining, there are six possibilities at the for the first position. For the second, remaining five. For the third, remaining four. If you want to use the formula, of course, we can use the formula. No problem. Look at this. The last position, of course, three ways. So, into three, right? And how many remaining we have remaining? Six elements left out because one has been put up here already, right? And then 6p3. That's all. Right? The three slots, remaining slots are there, and six. Very very simple. 6p3. So we go to the next question and tell me the answer for this. I will wait for your reply for 10 seconds. Then we'll go for the next. And be careful. We have a zero here. So be careful while solving it. 840. Pawan, my dear, check it once again. Pawan, just take the separate cases now. Separate case. Take separate case. The last digit should be. Srijit, check it once again, my dear. Check it once again. Srijit, check it once again. So Nikhil, check it once again. Dhanush, clean bold. Bhavna also wrong, my dear. Check it once again. Sunil, 1440. Check it once again. Suvarsha, check it once again. 840. Clean bold. Shreya, you also got clean bold. Sharanya, clean bowl. Try once again. Oh, I think this is a googly question, isn't it? Googly question this is. So we'll try all together. 6:30. Madhuri is telling 6:30. Neha is telling 6:60. Neha, no, wrong answer. Shreya, wrong answer. Hussein, wrong answer. Oh my God, everybody. Any smart, intelligent student? Surya 6:30, Meghna 5:60. I got your point. Why you were getting wrong? Nikhil, yes, Nikhil. Congratulations, Nikhil. I hope you got the answer, my dear. Let me check. Let me check. Watch out, everybody. So I'll try the same way, the fundamental counting principle again, and as a beginner. So the four-digit even number I need, right? So it means the last position must be the even number, isn't it? Yes, Nikhil. Yes, Nikhil. One, two, three, four. I need the even number, right? So I'll plug in zero here. Now first I will try what is the mistake you are doing. Everybody. Let me try first what mistake we are doing. Okay, 1 minute. Let me take this eraser. The mistake what we're doing. So I'll tell you what is the mistake we are doing. Many people would have doing this way. Yes, Neha, I got you. You will say fine. What could be here? It could be zero possible last position, zero, two, four, and six. So you will say yes, sir. It could be four ways here. One digit has been put up already out of 8 digits, and zero not possible. So you will say six here, right? So you will say zero not possible here. So we'll get six here and here five. I hope many of you would have done this way. Tell me yes or no. So 26 are 120 and 720, isn't it? Many of you did this way. So of course this is wrong, right? Why it is wrong, I'll tell you, Srijit. Give me a time, I'll tell you why it is wrong. This is not required basically because whenever you're putting zero here, so of course how many ways are possible here? Seven ways, right? So of course this is a contradiction. At the same position, I could not have the multiple ways at the same position, right? So I will break it. I will solve as a beginner. I'll break this one by one into different cases, ending with zero, ending with two, and then I will try this. So here we go. One, two, three, four. The last digit must be 0. I will get the even number, no problem. So I will get so many numbers end with 0, or I will get last position. Let's say I'm freezing 2 here. It could be the even number, or of course last position I can freeze it 4 here, or I can freeze it 6 also at the last position, isn't it? 6 also. Now I'll find how many numbers I will get ending with 0. Let's say, see, 0 has been already used up, right? Now come to the first position here. So how many ways are possible? Remaining 7 ways. Very, very simple. All together, how many is there? 8 digits are there. 0 has been put up already used up. I can't use again because without repetition, the question says, right? I can't use again the 0. So of course, any one among 7, I can put up at the first position. What about here? Second position. Of course, 6 ways. Remaining 6, isn't it? What about here? Remaining 5 ways. That's all. If you try this, how much you'll get? 6 fives are 30, 7s are will get 210. So I will get two 10 numbers ending with 0. Very, very simple. Sanket, I hope you got the right answer, my dear. Now remember, the last is 2 here. What about the first position now? Remember, 0 is available, right? I 2 has been used up. Remaining how many are there? Digits are there. Remaining 7 digits out of 8. Remaining 7 out of 7 also 0 I can't put here. So of course 6 ways. Now any one digit has been put off here except 0, and one digit has been put off here. Two digits have been put up out of 8, remaining again 6, because 0 I can use it here. 6, what about here? 5, right? I multiply all this, how much I'll get 6 into 6, 36 into 5, 180, right, Sankrit? If you look at remaining, this 3 is the same thing, isn't it? Exactly same thing, right? So 0 was the whenever you get the question out of zeros, there's the domain, the sets, right? So separate the case, right? So of course we go for this one also. We'll get the same here, 6 into 6 into 5. What about here? Again 6 into 6 into 5. So we'll get here again 180. I'll get again 180 numbers ending with 4, 180 numbers ending with 6, and 180 numbers ending with 2. So all together, what should be? It should be 200, 100, or 300, 500, 518, and 5, 6, 7, 50, isn't it? The answer is 750. Now remember, many smart people will not go this way. Many smart will go for just will make two case, that's all. One case with the 0 and other case with the non-zeros at the last, that's all. One case with the 0 here. So we'll get here how many ways? 7 into 6 into 5. And other case with the other not 0, non-zero digits at the last position. So 2, 4 or 5. How many ways? 3 ways directly. So of course 0 available, I can put 0 at the first position, right? So remaining 6 ways, I can put 0 here. Again 6 ways. What about here? Remaining 5 ways, right? So how much will get here? 540, and of course here I will get 7 into 6 to 10. So all together I'll get again the answer is 750. I hope you would have understood, everybody. Give me acknowledgement. Just tell me yes or no in the text in the chat group. Madhuri is telling to repeat once again. Madhuri, which one? The first approach or second approach? Okay. See, Madhuri, I will repeat the second approach. It's very, very simple. Look at here at this side. Yes, Nagma. The last digit should be even number. Very, very simple. Right? So I'll plug in the last. I freeze the last digit 0. I freeze the last digit 2. I freezed it 4. And I freezed it here 6. Now we'll try to. Okay, Madhuri. Now we'll try to arrange the remaining numbers different positions, right? Now when after freezing the last position, always we should arrange the digit from the first position. Now come to the first position. Now here 0 has been put up already. Out of 8, look at 1 2 3 4 5, there are 8 digits, remember, no? There are 8 digits. Out of 8, 0 has been used up, right? So of course 0 has been used up. I can't use 0 again. So 7 ways, right? Out of 8. Now remaining 6 ways, remaining 5 ways. Very simple. So it means 2 10 ways. Now non-zero. Now let's say I have a 0 here. Second, look at the second case. I freeze the only one digit 2. I freezed it. I fix it. I fix it. Now 0 available for me for this case. For this case. So I can't put 0 at the first position, because if I put 0 at the first position, it becomes the 3-digit number, right? So one digit 2 gone already. I can't use 2 at the first position. I can't use 0 also at the first position. So remaining, how many ways are possible? 1 possible, 3 possible, 4 possible, 5 possible, 6 possible, 7 possible. So remaining 6 possibilities are there, right? Now, one out of 8 digits, any one digit has been put up here. Any one, of course, 2 has been put up here. Out of it, 2 have been put up. Remaining again 6 ways, because 0 can be used up here. Can be, right? So 6 here, of course 5 here. So similarly, this case, and this case, Madhuri. I hope you understood, Madhuri. Thank you. We'll go for the next one, number 4, and tell me the answer for this. So I will wait for minutes. Anybody? Any smart, intelligent minds got the answer? Nagma, Sanat, Nidhi, Madhuri, please try. Very simple, no? The same fundamental counting principle, friends. 4-digit number again. 1, 1, 2, 3, 4. I hope everybody's know the rule of divisibility rule of 4. बताओ क्या होता है? I told you the last two digits must be divisible by 4, right? The last two digits must be divisible by 4. Harshini, Nikhil, I think a wrong answer. We'll try once again. Bhavna got the answer. Shujit got the different answer. Jamuna got the answer 160. Okay, fine. Can you check it once again, everybody? No, check it once again. Yes, got the answer, anybody? Nikhil got 500. Jamuna 160. Bhavna 240. Shrejit also got the answer. Okay. Okay, divisible by 4. Yeah. Chalo, we'll try now. We'll try. Can you tell me, everybody, if I'll find out the last two possibilities, last two positions I can fill up with the divisibility by 4, I will get the answer, Priyanka? Priyanka, let me try. Let me handle the situation and you watch out very carefully, everybody. Right? So I know whatever number I'll get it here, right? The last two digits must be divisible by 4. Very, very simple. So I'll find out the possibility of the last two digits, right? So let's see here. Can you tell me? We'll try to find methodical way. The multiple of 4. What's the multiple of 4? The first multiple of 4, 0, 4. That is not possible because 0 is not there. Next multiple, we'll say, oh sir, 1, 2. Possible 1, 2. I can plug in 1, 2. Right? 12 is a multiple of 4. Next multiple, 16. Right? Next multiple, 24. I can't take 2, 0, 20. Why? Because 0 is not there in the set. So 2, 0 is not possible. So 2, 4. 2, 8 not possible because 28. 8 is not there in the set. What is the other possibility? 32, yes, possible. 32 is a multiple of 4. Next, 36, possible. 40, not possible, my dear, because 0 is not there. 44, not possible because without repetition, I can't take 44. 48, not possible because 8 is not there. 52, yes, possible. Next, 56, pretty much possible. I can take this also. Can I take 60? 58? No, 60 I cannot take. 60, 6, 0 is not there. I can't take 6 also. Sankit, I hope you got the answer, my dear. Sankit, 64 possible, 72 possible, and 76 possible. Now I can't go ahead because 78. Next 80, 84. I do not have any digit more than 7. Right? So I'll stop now. So this is called traditional way of finding the multiple of 4 till the last, till the 76. Now, so how many we have multiple of 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 ways. It means the last two positions must be occupied by how many ways? 10 ways. Or remember, 12, na? This is or. I can plug in 12 or 16 or 24 or 32 or 36 or 52 or 56 or 64 or 72 or 76. I hope everybody understood now. Now or means what? Plus, one at a time. Now remember, now come to the first position. Any two digits have been used up out of 7. How many left out? Of course, you will say, sir, 5. I hope, Madhuri, you understood. So, any two digits have been used up at this place, at this place. Any two digits have been used up. Out of 7, remaining 5 is there. Now, what about the remaining 4? Just multiply. I'll get the answer. The answer is 200. I'll get 200 numbers which are divisible by 4. Yes, everybody, I hope you understood. So remember this, all the thought process is very, very important to point out. It could be any question, friends. It could be question now, find out the 4-digit number which are divisible by 5. So last digit must be 0 or 5. Very, very simple. Right? Now, can you tell me the same question with repetition? क्या आंसर होगा बताओ? With repetition, what should be the answer? So I will add one more. What is that? 44 I'll add, right? I will add anything we add if with repetition. So with repetition, what should be? I can't. 44 I can add. Yes. So one more. 11 should be here. What should be here? 7 into 7 into 11. I hope you understood with repetition, right? If it is a long numbers means I didn't get you, my dear. What is the Priyanka meaning? Long numbers? Talking about the set. Okay, you're talking about this number of sets. The maximum you will get 9, not more than that, because digits, right? Remember how many digits we have? All together we have a 10 digits. Of course, we will not get more than that because every position will occupy only one digit, Priyanka. I hope you understood. Divisible by 8, yes. Of course, should try for the last three digits, right? Last three digits, Srijit. Yes, Srijit. Last three digits. Shall we? I hope you can go for the next. Next, go for here. Tell me the answer for this. Very simple. I hope you will get the answer. Anybody? Anybody? 12. Dhanush got the right answer. Yes, Priyanka, very good. Srijit, Sanat Kumar, wonderful. Sanat, Srijit, wonderful. Right answer. Very, very simple. Four-digit number I need. One, two, three, four. Greater than 8,000. It means that at the first position, what should be? या तो 8 होगा या 9 होगा. Right? How many ways? Two ways. Right? Very, very simple. I hope you understood. Two ways. Yes, great. Meghna, Nagma, Lavanya, wonderful, great. Everybody solved it. Now, of course, we have only four. What should be the, how many ways are possible here? Without repetition. And anyone has been put up here, remaining three, remaining two, remaining one. Very, very simple. Surya, everybody, right answer, 12. Great. We'll go for the next one. Here we go. Be careful. Be careful. I'll give you time. Be careful solving this. Ananya, Pushkar, turn off your speaker. Ananya,
I'm not calling. मैं तो अपना फोन लेके
Ananya, turn off your speaker.
Mama, come. Take your phone. Come fast. Come out of the house. It's done. Mama, that's it. Last time girls sit taking photo था. Mama, you choose. Who's coming to kill me? Shit.
Anybody got the answer? 420, okay. 400, 420, 480. Dhanush, Priyanka, Nikhil. Try once again. I hope you got clean bold. Remember, zero is there, my dear. You know? Be careful. Zero को ध्यान से. You should handle zero very carefully. Zero is dangerous. Srijit, catch out. Srijit, check it once again. Watch out very carefully, friends. Suvarsha also, watch out very carefully. You should handle the zero very carefully in this topic. Shreya 735, Neha got it 40. No, I didn't get the answer. Priyanka and Suvarsha, I hope try once again, you can get the answer. Suvarsha and Priyanka, both. Sanat getting 430. Okay. Shall we try all together? Surya 450. Nagma 390. Sanat 430. Shreya is saying 735. Surya, no. Everybody got clean bold. Of course, so I can tell this is the googly question. Googly, isn't it? Chalo, we'll try this. Let's try out this question now, friends. Everybody. 312325 Hussein and Bhavana. Bhavana, you also got the wrong answer. 545. Hussein, wrong answer also. Oh my god, Dhanush, 280, 300. Shall we try now, Ishwarya? Everybody got clean bold. Sushmita 325, Sankirt 1170. Sushmita, you are very nearest to the answer. Nikhil 395, Rahul 390. I am reminding you once again, everybody, watch out very carefully. Zero is there. Chalo, we'll try all together. Let me solve it. And let's check what should be the answer. So 4-digit number divisible by 4, right? So 1, 2, 3, 4. Now tell me, everybody, should I make two cases or only one case? Aishwarya 450, Shreya no. चलो बताओ तो everybody just reply the question what I am asking. Two cases, right, Dhanush? Two cases, of course. There's zero is there, right? Two cases. So okay, great, Jamuna. Two case. So one case here, one case here, right? Rekha 346. Rekha, you were very nearest to the answer, my dear. I hope. I trust you will solve it. Try once again. Okay, two cases. Remember, for this case, I will try to find out the last two positions will be occupied how many ways. Right? Last two positions will be occupied how many ways. So let me try. And also here, the last two cases, the last two positions will be occupied how many ways? The multiple of 4. What is the first multiple? You will say 0, 4. Okay, I will write here 0, 4. First multiple. Second multiple 1, 2. I will write here 1, 2. Then 1, 6, 2, 0. Methodical way I am trying. 24, 2, 4, 2, 8 not possible. 32, 3, 2, 3, 6. Right? 3, 6, 4, 0. I write here 4, 0. 4, 4. No, not possible. Not repetition. 5, 4, 4. Then 5, 2. Yes, 5, 2. And 5, 6. Yes. 6, 0. Yes. Now, what about 6, 4? Possible. 6, 6, 4 also possible. 6 and 7, 6, 4, 6, 8. No, 7, 2. Yes. I'll stop myself because I'll get more than 80 now. 8 digits is not there. Out more than 7 is not given. Now, how many here? Non-zero at the last. 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Isn't it? 9 ways at the last position. Now, 0 available for me, isn't it? I can't put 0 here. There are 8 digits. Out of 8, 2 has been plugged in here, has been put up here. So 6. Out of 6, I can't put 0 also, so 5. 5 here. 76.
76 is also possible.
Yes, my dear. Yes, my dear. Yes, 7 is also possible. So how many altogether? All together will be 10, I think, right? Yes, dear. 10. So 5 here because 2 has been used up already out of 8, remaining 6. Out of 6, 0 can't be put up here. So remaining 5 and 0 can be put up here, remaining 5. Right, Jamuna, I got it. I got it. So what should be here? I hope you can solve it. 25, right? 25 into 10, 250. Who got the answer? I think someone got the answer 350, I think. So how many ways here? One, two, three, four. 4 ways. Remember, every time 0 has been used up, you should understand this point. And that's why I made a separate case for this. Every time 0 has been used up. So 0 not available for the first position. So how many ways? 6 ways. What about here? 5 ways. Isn't it? So 6 fives are 30 and 34s are 120. What is the answer then? Bhavna, you got the answer. 320 saying nearly 350. Rahul Kulkarni 345. अब तो आंसर बोल दो कितना आंसर है everybody. What should be the answer now? Dhanush, Sankit, Harshini, Bhavna, Priyanka. Right? I hope you understood. I hope somebody would have got this answer. Somebody got the answer. So I didn't under 370. Yes, Madhuri. Aishwarya, Surya, Priyanka, everybody. Right answer. Jamuna, I hope you also got this answer. Right? So just add together. So I'll get 370 total. Yes. Yes, Rahul. That is called the clean bold. No? Because once you forget any one, of course, will be bold. Right. Anyway, Rahul will go for the next one, next question now. Yes, so that's why I'm telling you, friends, remember, just go methodical way, na? The first multiple, second multiple, third multiple, fourth multiple, go methodical way. Don't take randomly. So please listen very carefully. Many beginners, what they do, we find randomly the multiple of 4 out of the sets given. Don't do that. Just go methodical way, traditional way. So the first multiple, fourth, second multiple, third multiple, and check whether possible or not according to the given digits in the set. Right. So this is a very, very important point. So here we go for now. We'll try arrangement of letters or objects or persons. How do we arrange it? Right? Let's say one name. The name is, let's say the name is, there's one word, great. G-R-E-A-T. Acha, how many letters are there altogether? The 5 letters altogether. Let's say I am creating the 5 positions. 1, 2, 3, 4, 5. It means that number of slots and number of elements equal, isn't it? The 5 letters, I am creating 5 positions. Of course, the non-living things, letters, right? Object. So of course, one letter will occupy only one position. So what should be? Can you tell me how many ways I can arrange at the first position? I can put in the first position of how many ways? Different letters I can put it here. 5 ways. Remaining 4 ways, remaining 3 ways, remaining 2 ways, remaining 1 ways. So can I say, friends, if number of elements and number of slots are equal, I can say 5 factorial. It means if number of n and number of r equal, the number of arrangements. So what should be? Number of arrangements should be n factorial. Very, very simple. When? When without repetition. Without we have seen already now, let's say a number of n 5 members, right? 5 people and 5 chairs, right? 5 chairs. So of course I'll get 5 factorial ways, right? The person can sit to the into the different chairs. With repetition, what happened, right? Of course, with repetition, if you try look at this, the 5 slots. So 5 ways here, 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 5 to the power 5. It means that with repetition, n to the power r, right? Number of slots and number of elements are equal. So number of arrangements without repetition is n factorial. As we know that, just I wanted to remind you. And with repetition, it could be n to the power r, 5 to the power 5. Very, very simple. So now we'll try to arrange the letters of different types of problem. We'll try this based on this. So number one, dive into the question directly. Yeah, here we go. Simple. Get me the answer for this. Very, very simple. What is the answer for the first one? Jaldi bata do answer. First one. Wow, very nice, very nice. 5 factorial. No, nothing else. 120, right? 5 factorial. What about here? Second one. If repetition of alphabets allowed, it means that 5 to the power 5. Wonderful. Great. Everybody got right answer. Here we go for the next slide. Next question. Yeah. Tell me. Very, I mean, the typical classical question, no, for the placement point of view. How many words with or without meaning can be found by using all the letters of the word Allahabad? Right. So I hope you know this. So what we'll do, we'll count the number of letters first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So nine factorial ways we can arrange the letters. But remember friends, but there are the few letters are repeated. Let's say A repeated how many times? A repeated how many times? The 4 times. So I should divide by 4 factorial. Why I am dividing it, you should understand, because if this A will go anywhere at the respective position, does not make any sense, right? Will be the same arrangement. Just to avoid the repetition, to avoid the redundancy, I am dividing by the number of factorial. So A repeats 4 times, divide by 4 factorial. If you watch it very carefully, also L repeats how many times? 2 times. Look at this, L 2 times. So again, divide by 2 factorial. Yes, Sankirt and Nidhi, congratulations, right answer. So 9 factorial divide by 4 factorial into 2 factorial. तो कितना आंसर होगा? 7560. Right answer, everybody. It's just matter of solving here. 9. I hope you'll get the answer. 9 into 8 into 7 into 6 into 5 and 4 will get cancelled. Divide by 2. Isn't it? We'll get the answer. 36 into 7 into 30. So 36 into, let's check it out, right answer or wrong. 36 into 210. So 21 6 are 6 5 21 3 are, so 7 0. Yes, 7560 is the correct answer. Now engineering, tell the answer for engineering. Count the number of letters: 1 2 3 4 5 6 7 8 9 10 11. Can I say 11 factorial? No problem, I can arrange. But some letters are repeating. E repeating how many times? E repeating, I think 3 times, isn't it? 1 or 2, 3 times. E repeats 3 times. And N repeats again 3 times. Right? And anything else? I repeats how many times? 2 times. And G repeats how many times? 2 times. Wonderful. I hope you get the answer. 277200. Wonderful. Right? Neha, Priyanka, Sonali, Sharanya. Wonderful. Great. Here we go with the third one. So Ready for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are given. So I can arrange in how many ways? 11 factorial ways. Divide by. So I how many times repeating? 4 times. I repeats 4 times. And S how many times? 2 times. 2 factorial. And C how many times? 2 times. Again 2 factorial. And again P 2 times 2 factorial. The answers I'm leaving to you. Right? Just the pencil work. You should do that. Wonderful, great. I hope you would have understood this is a classical question we would have studied already. So I wanted to remind you once again. Here we go for the next one, number 3. The vowels are together. Tell me the answer for this. The vowels are together. How many 5-letter words can be formed using the letters of the word great such that all the vowels are together? The great, है ना? The word is given here, great. Vowels must be together, so I will keep all the vowels together. Let's two vowels, E, A, I'll keep together. What about remaining? G, R, T. Yes, Nikhil. Nikhil, I hope you got the right answer. We'll check it out. We'll check it out. So vowels are together means, so can I say that if the vowels are together, I will keep all the vowels at one place. Let's say I will keep inside the box, one box, right? So I will keep these consonants in the separate boxes. Why is that, friends? Remember, I am keeping this because now I will arrange the boxes now. If I arrange the boxes, so whenever this box, the bigger box, which one bigger box? The vowel box will go anywhere, will go together. The two vowels are together, right? So how many boxes are there? There are how many boxes? There are 4 boxes. So 4 boxes, 4 positions, how many ways? 4 factorial ways. Now inside the box also I can arrange how many ways here? 2 ways. You know? There are 2 vowels inside the box. So I can also rearrange inside the box. It's been internal rearrangement. How many ways? 2 factorial ways. So answer is 4 into 3 into 2 into 2. Yes, everybody. Right answer. 48. Right? So I will get 48 words. Such words where the vowels must be together. Always be together. So remember, whenever given the vowels are together, so I will keep all the vowels inside the one box and remaining separate boxes. Now let's say consonants are together. So I will keep all the consonants in one box and remaining letters in separate boxes. And then I will rearrange the boxes now. After arranging the boxes, then I will arrange the vowels inside the box. That is called the internal rearrangement. That is 2 ways. You know? I hope you understood. Everybody. Can you tell me for this? Tell me how many ways you can arrange this word such that vowels are together. Batao. Such that vowels are together. Toronto. Toronto. How many ways you can rearrange the word Toronto such that vowels are together? Sankirth is saying 360, Nikhil is saying 120. Okay. Are you sure, Sankirth? Let's try. So we'll count 1, 2, 3, 4, 5, 6, 7. 7 factorial. Any repetition is there? And first I will keep the vowels together. I know. So vowels O in one box. What about remaining? T, R, N, T. Right? So how many? 7 letters. 1, 2, 3, 4, 5, 6, 7. Yeah. So I'll keep all these remaining consonants in separate boxes. Separate boxes. Now I will rearrange the boxes now. So Varsha got 60, Nikhil got 60. Let's check it out. So how many boxes altogether? 1, 2, 3, 4, 5 boxes. So 5 boxes will occupy 5 slots. So how many ways? 5 factorial ways. So any boxes repeating? Yes, 2 boxes repeating. Which one? This 2. This box repeats 2 times, so 2 factorial ways. Now, after this, can we rearrange the inside internal rearrangement? There are three O's. I can rearrange 3 factorials divided by 3 factorial. Does not make any sense, right? So what should be the answer? So 5 into 4 into 3 into, that's all, right? That is 1. 2 will get cancelled. This is 1. Yes, my dear. The answer must be 60. I hope you would have understood everybody. So everybody, I would have understood it. Prakriti, Priyanka, Shreya, wonderful Shreya. Great, everybody. Good job. Shall we go for the next one now? If you tell me yes, now try this. Yeah, fast. How many 9-letter words can be formed from the letters of hyperbola if the letters P, E, R must be together? जल्दी बताओ आंसर यार, बहुत सिंपल है. I hope you will get it the answer. 720. Okay, Shreya got the answer. So hyperbola, so who must be together? PER. So PER, I'll keep inside the box. Remaining क्या क्या बच गया अभी? H, right? Then Y, right? Then B, the O, L, A. So I'll keep remaining consonants inside the separate boxes, right? So I hope you would have understood as of now why I am keeping inside the separate boxes. Now I will arrange the boxes. How many boxes altogether? 1, 2, 3, 4, 5, 6, 7 boxes. 7 factorial. 7 boxes will occupy 7 slots. So 8 and R equal 7 factorial. Now check, is there any box repeating? No, not at all. Now also I'll rearrange this box inside this box. How many are given there? 3 factorial. No arrangement. That's all. That should be the answer. I hope I'm leaving to you to solve this one. 7 factorial into 3 factorial. 7 factorial will get how much? 120. 50 something will get 120 into 6. 720. 720 into 7. You know? Yeah. So I hope you'll get this answer. 9-letter words can be formed from the letters. Is 9 letters of a word, my dear? 1, 2, 3, 4, 5, 6, 7, 9. 9 only, no? Bhavna, I hope you confused. Why I'm keeping inside the box is this box can go anywhere. This box can go here. This box can go here. This box can go anywhere, right? So we'll go together. So I will have to include the count the number PER also, right? I am keeping inside the box just to make all these 3 letters together, nothing else. 3 best friends, no, tie them together. So whenever they will go together. So arrangement is happening here, but these 3 letters will go together anywhere. So just you can assume 3 best friends, and all the 3 best friends should be tied to each other, right? Where we go for the next one is that is here. Simple, tell me the answer fast. How many arrangements of the letters of the word Bengali can be made if the vowels are never together? Can we say that if vowels are never together, it means consonants are together? Can we say that? We cannot say that, remember. If the vowels are not together, it does not mean consonants are together. Never. Right? Never. I'll give you one scenario. One scenario. Take one instance. Let's say E is here. E, B, G, I, N, A, L. Look at this. Right? Vowels are not together. It does not mean consonants are not are consonants can be together, cannot be together. It's not sure that, right? And consonants are together is always true? No. Right? So what we'll do? How to find out? I'll find the complete number. Right? Bengali, this word has been, how many ways you can arrange this word Bengali? Right? So how many altogether? 1, 2, 3, 4, 5, 6, 7. 7 factorial. Right? Now minus the vowels are together. Keep the vowels all together here. E. What is the vowels given? E, A, I. Vowels are together. So I am subtracting from, yes, my dear. I hope you got it. Dhanush, right answer. Remaining is what is given? B, N, G, L. So I will keep the consonants in the separate boxes. Separate boxes, right? So 7 factorial minus what should be here? Tell me. 1, 2, 3, 4, 5 factorial. No repetition. Inside the boxes, I can also rearrange 3 factorial. That's all. So 7 factorial minus, how much will get? 720 here. How much 7 factorial? Of 720 into 7. 5040 minus 720. Answer must be 4320. Wonderful. I hope many of you got the answer. So I am subtracting, right? All vowels are together. I am subtracting. This case, how many words we can form where all vowels are together? I'll subtract from the total arrangements, right? So I will get vowels are not together. I hope you understood. So question number 2, you will try yourself. Just take this as a screenshot. Try yourself. Now we'll go for the next question, number 6. Yeah, here. Tell me. Arrange 5 boys and 5 girls such that no 2 girls should sit together. Right? Ajay, look at the second question also. Girls and boys should sit together. Should sit alternative. Ajay, can you tell me this both questions are the same or different? Both questions are same. Are these questions same or different? Bhavna is telling different. Wonderful, Bhavna. Then you understood then try solving it. Dhanush is not the same, my dear. No 2 girls should sit together means, what does it mean? It means that boys can sit together, right? Boys can sit together. Boys can sit together. Uh, no 2 girls should sit together. It means boys can sit together. Second one, girls and boys should sit alternative. It means no 2 boys should sit together. No 2 girls should sit together. Both are different. इसका मतलब क्या हुआ? No 2 boys and no 2 girls should sit together. It means that two boys can sit together. No? Boys can sit together. So both questions are different. How do you solve it? I'll give you a standard approach to get the answer. Listen very carefully. A very standard approach is, of course, for the boys, I do not have any condition. No, will be different, my dear. Will be different answers. I will tell you how. Sonali, I will tell you how. Remember, no two girls should sit together. But try to understand this way. Uh, First, I will arrange the boys because we do not have any condition for the boys. How many boys? Five boys. Let me arrange the boys first. So B, let's say B1, B2, B3, B4, and B5. Now, of course, girls can sit in these positions to maintain the condition. If you tell me yes or no, tell me yes or no, right? So what I'll do, I will arrange first boys because there is no condition given for the boys. So what should be the answer for this one? So I'll arrange the boys all together. 1, 2, 3, 4, 5. So 5 factorial. Boys arranged already. Now how many girls? 5 girls. Now for the 5 girls, how many we have positions created? 1, 2, 3, 4, 5, 6. The first girl will have how many options? 6 options, right? Isn't it? Now the second girl will have how many options? Remaining 5 options. Third girl remaining 4 options. And the fourth girl remaining 3 options. And the fifth girl remaining 2 options. Now I'll tell you what does it mean. Let's say G1 is here, G2 is here, G3 is here, G4 is here, G5 is here. See what is happening. Can you tell me what is happening now? You would have understood B, there is nothing called the gap. This is the virtual gap. No, remember, there is nothing called the virtual gap. So B3 and B4 sitting together because there is no gap here. There is no gap. So B and 3 can be sit together. So I'm talking about the one instance, right? It is a many instance. It quite possible G1 can be here, right? And G1 not be here. That's all. That becomes the alternative. So no two girls should sit together is also the we'll get one more case, alternative case, right? And also the two boys can be sit together. That case also, right? That's why I will arrange the boys first and then I will arrange the girls in the respective positions, right? So I will give you one more idea to get this answer. I will erase this first. I will make you understand once again what is happening. Right. Look at this. So remember Sonali, I am not arranging in a circle. This is not circle. This is a linear arrangement. We'll try to discuss the circular arrangement after some time, Sonali. This is a linear arrangement. I am talking about the linear arrangement now, not the circular. Now, boys are arranged first because no condition. B1, B2, B3, B4, all the 5 boys I will arrange. Now, of course, we have the gap created. You know, these are the gaps. Now, so 5 boys can occupy 5 factorial ways. They can rearrange themselves. 5 boys can rearrange themselves in 5 factorial ways. Now, remember, the girls have there are 5 girls, but 6 positions created. But I need only 5 positions. Anyway, of course, the virtual gap would be vanished. So what is happening here? The first girl, how many options we have for the first girl? 1, 2, 3, 4, 5, 6. Of course, 6 options. Let's say first girl occupying this position. Now, next girl, of course, we'll have a 5 options remaining. Let's say second girl is here, right? Done this also. Third girl, how many remaining? 4 positions. Let's say third girl is here, G3, right? Now, fourth girl, remaining 3 positions for the fourth girl. Let's say fourth girl is here, G4. Done. Now, fifth girl, where can be anywhere, right? So how many remaining? 2. Let's say fifth girl is here. देखो क्या हो रहा है? It means there is no gap here. There is no gap here. It means B1, B2 can sit together. Remember, friends, I am showing you one instance. We'll get so many instances like that. It's quite possible B2 and B3 can be sit together. B3 and B4 can be together. B4 and B5 can be together. Right? So this is very, very interesting. That's why I am arranging first boys, because no condition. Right? That's why I'm saying I'm telling you there is called something the virtual gap. If there is no person in between, it means no gap. Very, very simple. Let's say there are 3 persons sitting on a bench, 3 person, right? So I can say there's a gap in between the two because one person is sitting here, right? So remember, this is the traditional, not traditional way, I mean standard approach to get the answer. What about the second question? Remember, no two boys can sit together, no two girls can sit together. It means alternative. It means that I can tell boys, girl, right? Boys, girl, boys, girl, boys, girl, boys, girl. That's all. 1, 2, 3, 4, 5. That's all. How much you get? 5 factorial into 5 factorial. Remember, now it possible boys, right? Starts with the boys. It quite possible it starts with the girl. Why not? G, B, girl, boy, girl, boy, girl, boy, girl, boy, and girl, boy. Why not? Right? Also possible. Again, we can arrange how many ways? 5 factorial boys, and in how many ways? And 5 factorial girls we can arrange. It means that, can I say 2 into, right, 5 factorial into 5 factorial will get the answer. So what should be the answer then? A very, very huge answer will get it. Very, very simple. I mean, just I'm adding it, nothing else. Just I'm adding the both, this two, or condition, adding it. So both questions are very, very different, friends, remember. Anyway, I will try. Now we'll try, last question we'll try, we'll go for this, the quiz now. Very, very important. We'll go for circular, because Sonali was talking about circular. Yes, Dhanush will try. Of course, you will get the answer. The circular means, what is that? Remember, this is. I'll tell you very fast what is circular means. Hence, no time. N minus n factorial. That is the formula. N minus, let's say 58 members sitting round a table. So how many ways they can sit? 58 minus 1 factorial. It means 57 factorial. Why this is happening? I'll give you a clue. You try solving yourself. Just try thinking and develop the thought process regarding this. Remember, let's say there is a one circle is given here. Person A, B, and C, right? So among 3 members, of course, I will not rearrange everybody. Not possible. This is circular here. I hope you are listening, Sonali. Right? So I will make any one person constant, and I will. So 10 more minutes, my dear Nikhil. 10 more minutes. Let's say the 3 person sitting round a table. So I will arrange any 2 members out of. I will keep one person constant. Remember, among 3. There are 3 members A, B, and C. So I will keep one person constant. Remaining 2 I will rearrange. How many ways? 2 factorial ways. Let's say 100 people sitting round a table, right? So of course I will keep any one person constant. I will rearrange the remaining. It means I am arranging n minus 1 factorial. I am not arranging n factorial, right? It means I am not arranging complete number, total number of people. I am arranging remaining, how, except one. Very, very simple. Except one, I am arranging it. So keep one constant. Look at this. Keep any constant. You will get the answer. Let's say A, B and C. A, B and C. 1 minute. Okay, this is C. So let's say I'll keep A constant, right? I will arrange here. C can come here. B can go there. That's all. Only two ways we can see that we can arrange. Not more than two ways, right? So also you can find out who is right of A, right of C, or left of C, right of B, left of B will get different, right? I hope you would have understood. Remember the first, this is the what I did the first one. Without changing the neighbors, only changing the sets will not change the circular permutation, remember. What is happening? Just I'm rotating it, no? Rotating it. It's all the same. Who is the right of A in the first figure? Right of A, that is C, right? Look at here. Right of A, here B. Look at this. What is happening? Changing the position, that nothing else. Uh, we'll go for the questions. We'll try the questions first. And one more trick is there. The formula is n minus 1 factorial divide by 2 for which case? For the necklace case. Necklace question. Necklace, garland, bracelets. Right? So what is the n here? Number of beads. I hope you understand what is the beads meaning. Number of beads. Right? So anyway, I will try this. The questions based on this. Yeah. Tell me the answer for this. In how many ways can five friends sit around a table? Very, very simple. Round the table. Around the table. It means I'll keep one person constant. Very, very simple. The 4 factorial. That is 24. Very simple. Yes, everybody. Go for the next one. And then we go for the quiz also. How many necklaces can be formed with 7 different beads? So what happens here? 7 different beads. 7 minus 1 factorial divided by 2. Remember, because in the case of necklace, so 6 factorial divided by 2 must be the answer. Yeah. Here we go for the next one. Here. In how many ways can 4 boys and 4 girls sit round a table if boys and girls should sit alternative? Yes, alternative. One, two, three, four. 4 boys, let's say boys given here B1, B2, B3, B4. Acha bolo, how many ways you can rearrange the boys? How many ways? There are 4 boys, and boys can move, can be arranged on their respective positions. It means boys' position, right? So how many ways? 4 minus 1, 3 factorial ways. Now remaining girls, let's say G1, G2, G3, and G4. 4 girls. So of course, remaining girls, how many ways they can be rearranged? Of course, 4 factorial ways, isn't it? Why is that? No, I can't subtract once again because I have done already here minus 4 minus 1 factorial. Remember, isn't it? 4 minus 1 factorial. So remaining girls, of course, there are 4 girls remaining. I can rearrange in 4 factorial ways. So 3 factorial means how much? 3 into 2. So 4 into 3 into 2 into 1. How much? I hope you will get the answer. Yes, my dear. Surya Sanket, right answer. Very simple. Now we'll go for the quiz now, and then we'll wind up. A quiz link I will share with you just in 2 minutes. Give me time. I got the link. I hope you got the link. Thank you. Thank you. Yes, everybody, solve it this the quiz. And then reply me. We'll discuss the quiz question. Then we'll wind up. Once you finish the quiz and tell me, please, everybody. Did anybody finish it? You can reply me in the text once you finish the quiz. Okay, Sanjana finished it. Great, Sanjana. How was the question, Sanjana? And how many of you got correct answers? Great, Sanjana. So how many of you got correct answers? Out of, I think total number of quizzes are 7 would be here, right? 6 or 7. Shreya, great Shreya. Shreya, how many got the marks out of 7? How much marks? How many correct answers? 7. Great, great. Srivatsan, Srivatsan, how many Neha? Neha, how many got the correct answers? Dhanush also finished 6 by 7. Great, Neha. That's good marks. Srinivasan 6. Sharanya, great. Sonali completed Jamuna, done 7. Wow, great. Congratulations. All the best for the placement. Great, Jamuna. Yes, please reply fast if you completed, you finished it. So we just I will show you the questions quiz. What should be the answer of the quiz? Was completed, done. Shreya, Rahul, Aishwarya, wonderful, great people. Shreya, great. I hope almost you would have finished it. So we'll discuss this question. Quiz number 1. Very simple this is now. How much you got the answer for this? How many 4-digit number can be formed with digits 1, 2, 3, 4 and with distinct digits? Only 4 digits given, right? So 4 into 3 into 2. Very, very simple, I think. Right? 4-digit number. Isn't it? Great, 24. What about this one? Word strain? Very simple, no? 5 factorial, I think, isn't it? 120. And what about this? Which is the correct option? Wrong, wrong, right, wrong. Right, right. Because 4 factorial, how do we write? 3 factorial into 4 we can write, isn't it? So we'll divide. We'll divide. So next one. Next one is fourth one. What is the answer for this? In how many ways can the letter of the word triangle be arranged? What is the answer you got it? 6 factorial into 4 factorial. Alright, that's all now. 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial, right? Is there any repetition is there? Okay, okay, fine, 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 fine. So and there is any repetition is there? No, no, Triangle. No, that's all. Good. So next one. Yeah, this one, what is the answer for this? In how many ways can 4 girls and 5 boys be arranged in a row? All the 4 girls are together. How many girls all together? 4 girls. Keep it one. You know? Our boys must be separate, isn't it? Separate. So separate boxes, I can say. Separate boxes, I'll keep it set. So altogether, how many? 1, 2, 3, 4, 5, 6. 6 factorial into inside the this box 4 factorial. Right? Great. Inside the boxes, right? So this will always be together. So I will rearrange all the boxes first, 6 factorial ways, and inside the box there are 4 girls. Also, we can rearrange them among themselves, you know, among themselves. Right. Here we go. What's the answer for this? Cannot be together. So complete factorial 9 factorial and be together. And 5 factorial into 5 factorial. I hope you would have got the answer. Great. And what about this? How much you got the answer for this? 25 gangster, including 2 brothers, Munda, Mobile, and Papu Pager. In how many ways can they be arranged around the circular table if there is exactly one person between these 2 brothers? Yes, the right answer. Because remember, there are 23 ways the 2 brothers can sit. I mean, one person can be in between the 2 brothers, right? 23 ways, and remaining 22 factorial ways they can arrange, and the 2 brothers can be also arranged in two ways. So it means that 22 factorial into 23, 23 factorial into 2. Very very simple. Number 1. Okay, Dhanush. Right. So we'll wind up now. We'll try this the next session. This all remaining, right? And or the other time we'll schedule the time for the remaining. There are 2 more. There's only one chapter left, that is a combination and the application of combination. 2 chapters basically, right? So we'll try this in the next session. I have another meeting. So I have another meeting on Zoom, that is 7:55. Now is already 48. Thank you so much, everybody. Of course, today the session was not so smooth because of the first 1 hour. So that's for that. I appreciate that you were there, and thank you so much. We'll see you in the next session. Dhanush, thank you so much, my dear. Bye bye. Shreya, thank you. And all the best, Samuna, thank you. Soumya, Dhanush, everybody. Sonali, all the best. Thank you. So we'll see you the next session. Harshini, thank you, Harshini. Harshini, great. Keep trying, keep solving the question. Sharanya, thank you, Sharanya. Great. All the best. Priyanka, thank you. Sanat, well done. Good, Sanat. I hope you must be trying and just solve the assignment question also out of the permutation basically, and the combination will try this. Okay, Sanat, right. Thank you, everybody. So thank you, the team, Genesis team, technical team. Thank you so much. So I am winding up the session.